Good morning, and we are now finished all of the new things within the straight line for the higher course. Got a heading here, the distance formula, but this is not new. This is something that you will have met, or you should have met, at National 5, but I'm reminding you of it just now because you're about to do an exercise that has a mixture of everything you've done so far, and some of the questions will involve you having to work out the lengths of sides in right angle triangles or different shapes to be able to make conclusions about those shapes. Okay, so I'm just going to remind you about the distance formula. So if we have two coordinates x1 and y1 and x2 and y2, then this is the distance formula. So it is the square root of the difference between your two x's squared plus the difference between your two y's squared. Now, please try to remember when this was introduced to you at National 5 that the distance formula is actually basically Pythagoras' theorem. Okay, if you have a right angle triangle, then the difference between your two x's is your horizontal distance. So that number there squared is where that comes from. And then the vertical height is the difference between your two y's. So you would square the two numbers on the right angle triangle and you would add them together. And then the final thing you would do would be to square root them, and that would be to find the hypotenuse of the right angle triangle. Okay, so that's what the distance formula is. So it really is just Pythagoras. Okay. Let's look at an example. Find the distance between these two coordinates. Now I'm going to show you two methods for this. One using the distance formula and one using a more common sense approach if you get mixed up with lots of different formula, because the distance formula is definitely not on your formula list. Okay, so if we're going to do this as using the formula, then the distance between the coordinates A and B, we call it AB. So we're going to do -4 - 1, substituting everything into the formula, all squared, plus, and then 5 - 2, all squared, the difference between your two y's. -5 squared plus 3 squared, 25 plus 9, 34. You can just leave it as root 34. Or you could work out what the square root of 34 is as a decimal if that was going to be beneficial to you within the question. Okay, sometimes just leaving it as a surd is absolutely fine. And sometimes there might be a reason that you want to turn it into a decimal. If you're asked for an exact value, obviously you would leave it as a surd. But the other method is just really using Pythagoras by working out the difference between the x's and the difference between the y's. So look at your two x's. If you were thinking of those as being the horizontal part of the triangle, then look at your two x's. What's the difference between the number 1 and -4? From 1 to -4 is a difference of 5. And from 2 to 5 is a difference of 3. So you could just go straight into the difference between the two x's rather than putting them in formally like that. The difference between the two x's is 5. The difference between the two y's is 3. So notice we don't have a negative anymore, but that's absolutely fine because when you square that number anyway, it becomes a positive, so it doesn't matter. And it still leads to the same working and the same answer. But without that formula there, because I think personally that's quite complicated and people can get mixed up with it. If you just think of it as the difference between the x's, the difference between the y's, you square them and add them because you're finding the hypotenuse in a right angle triangle. That will lead to the same answer. So you're going to be doing some questions which have a mixture of all of the different things that we've been doing in the straight line topic so far. So you might have something involving the gradient being equal to the tan of the angle. You might be asked for a perpendicular bisector. You might be asked for a median or an altitude. Okay, whichever one you're asked to do, you might be asked to make a conclusion about the type of triangle, if it's an isosceles triangle. And if you wanted to know if something was, say, isosceles, you would want to work out that two of the sides were the same length. The third side is different. And for things like that, that's why you might want to work out the the distance between coordinates to work out lengths on sides of things. Okay, so useful when the straight lines make up a two-dimensional shape and you're asked to maybe calculate the area as well. That might be another reason that you'd want to work out the distance. Okay, so we're doing exercise 1N now, which is a mixture of lots of different things that you've been doing so far. And if we could do questions 1 to 4, that gives you a little mix up of all the different questions there, but feel free to do some of the extra ones if you want to. There's also a mixed questions after that as well that you can work through, particularly those ones that have the word higher beside them. You can work through those. They are from past papers from quite a few years ago, but they are from past paper questions, and that will give you an indication of the types of questions and how they can come up in the exam. Okay, so remember to ask your teacher for help. Let your teacher know if you're having any problems, and take care and good luck. Bye.